All right. Well, how's everybody today? Doing good, 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 good. Okay, we don't have a whole lot to do. What I do want to do is just remind you about how to use a matrix to solve a system, because I think that's going to be helpful to you down the road. Once we're done with that, we're on SEL, so it's going to be an easy way to end the week. Just going into next week, our last week before another big vacation. So all we got to do is get through one more week. But on Monday, I've got a little packet for you. We're going to review for the district assessment. Tuesday, Wednesday, we're taking the district assessment. Yes, sir. We're taking the district assessment on Tuesday and Wednesday. Yes, it's over 2 days. Mm-hmm. Mm-hmm. Do it in class. And then at the end of next week, I'll go ahead and introduce exponentials to you, and then we're on vacation. We're going to take some time off. All right. So if you will pull out that paper from yesterday, and I do have extra copies in case anybody needs one. Would you pass that? There we go. Okay, anybody else? Cool, cool, cool. All right. So let's go to the side that's talking about a determinant. We're going to go ahead and use Kramer's rule. So if we go ahead and scroll down, we've already worked number 6 and 7. Okay, what I'd like to do is go ahead and work number 8, but I want to go ahead and work it both ways, because I want you to see that it's just a strategy. It is always up to you how you want to go ahead and solve these problems. Even if I solve by elimination or substitution, it's still going to give me the same answer. Okay, in the calculator, same answer. All right, so let's go ahead and create our 3 matrices. So we have matrix A, we have matrix X, and we have matrix B. Okay, now remember the dimensions for A was 2 rows by 2 columns, so it's a 2 by 2, but both X and B, they're 2 by 1 matrices, so 2 rows and 1 column. So can anybody tell me what's going in the top row for matrix A here? -6 and -6. See, I'm taking those coefficients just directly out of the system exactly as I see them. So what's the bottom row going to be? 1 and 1. That's why we call it the coefficient matrix. Okay, we just use the coefficients. Okay. Now, matrix X, well, those are the 2 variables that you're trying to solve for. So that's just X and Y. And matrix B, we call it the constant matrix because it's made of the constants. So I'm going to put a -30 up top, and I'm going to go ahead and put the 2 down below. This is what the equations equal. Okay, so everybody's okay with that. Well, here's your matrix equation. You would take matrix A times matrix X, and that would equal matrix B. Now, if we're solving for the unknown here, X, we would take the inverse of A times B. This is what's key. Okay, that's what you want to go ahead and put in the calculator with your matrices. The inverse of A times B. All right, so let's go ahead and pull up the calculator here. So matrix A is a 2 by 2. So I remember, let me go ahead and document B out of that. If I go ahead and hit this button right here between 9 and the open book, right below delete, this brings up so many useful items. You got fractions here, powers, radicals. You can create piecewise functions, absolute value. But if you look in the second row, this is where you have templates for your matrices. Okay, so matrix A is a 2 by 2. So this is the one I'm going to choose. And I believe it was -6 and -6, and then 1, 1. Okay. Now, here's what you want to do. Once I've got matrix A in there, I'm going to use my touchpad, the arrows. I'm going to put the cursor outside the matrix, and I want to raise this to the -1 power. So I'm going to use that button on the left that looks like a house. Okay. Call that the caret button. So I'm going to put -1. Now, here's super important. You want to hit the right arrow key one more time to make sure the cursor is no longer in the power. Okay. Now, I don't even have to hit times if I want to. Go ahead and go back to this button here that brings up my templates. Matrix B was a 2 by 1, so I want this one. Well, what were my 2 numbers? -30 and 2. There we go. So the inverse of A times B, the second I push enter, why did that happen? Singular matrix. Huh? Ah, that's why. Okay, so we didn't do anything wrong. This is exactly how you would solve the problem. I just didn't look at the answer before we started. If you go ahead and do this and it gives you an error message, what do you think that could possibly mean? There's no answer. There's no solution. So there's no solution to that system. So if I were to go ahead and solve it using any other method, I'm going to come to the same conclusion. Okay. All right. So there are no ordered pairs X and Y if I make both those true at the same time. Okay. Now, because that one turned out to be a no solution, well, instead of working this one, number 8, with Kramer's rule, why don't I just go ahead and do number 9? I think at least that was good that you got to see that in case that ever pops up. Okay, so let's solve number 9 using Kramer's rule. Okay, now for Kramer's rule, you're setting up 3 matrices. Okay, it was called matrix D, D sub X, and then D sub Y. This is another strategy for solving a system using matrices. Okay, all of these are 2 by 2s. So I'm going to go ahead and get my matrices ready. Okay. Well, we call matrix D the coefficient matrix because I'm going to use what? The coefficients. So let's do the same thing. What are my top 2 coefficients from my system? -6 and 3. Because see, that's exactly what we have here in my top equation. So what would the bottom one be? Okay, -1 and -5. Now, we started talking about Kramer's rule yesterday. This is where the constants are going to play a more important role. Okay, so my constants in this case, they're the 6 and the 23. For D sub X, you're going to replace the X coefficients. For D sub Y, you're going to replace the Y coefficients. Okay. So instead of having the coefficients -6 and -1, I'm going to put in 6 and 23. The Y coefficients stay the same. That's still 3. That's a -5. For D sub Y, we replace the Y coefficients. So instead of the 3 and -5, that's now the 6 and the 23. Okay, the X's are going to be just the same, -6 and -1. Is everybody okay how I set up the matrices? Okay. Now here's how we go ahead and find the determinant. The determinant is a number associated with a matrix that helps us solve systems. So we're always going to start on this diagonal. We're going to go from the top left to the bottom right. Okay, so what's a -6 times a -5? So that is a +30, and we will always subtract the product on the other diagonal. So -1 times 3, well, that's a -3. Okay. But what happens when you subtract a negative? You add it. So 30 plus 3, we're actually looking at 33. Okay. So that's my determinant for matrix D. Okay. And now we're going to do the same thing for the next one. Okay. Let's see here. I need a 6 times a -5. So that is a -30. We always subtract. Well, what's a 23 times 3? 69. Well, I'm looking for a -30 minus 69. -99. Okay. There you go. And then try the last one. See if you can find me the determinant for D sub Y. Okay, but don't say it out loud just yet. Yes. Okay. Okay, so let's see. -6 times 23 is a -130. Okay, 8 or 38. Okay. And then we're going to subtract. -1 times 6 is a -6. So what's a -138 plus 6? negative 132. Okay. Now, once you have your three determinants, is everybody okay how I got that? Okay. Well, this is how you find your answers. X is going to be d sub x's determinant divided by d. Y is going to be the d sub y determinant divided by d. Let's see, for x, that would be negative 99 divided by 33. So that's a negative 3. So I know the x is a negative 3. For d sub y, I'm going to be looking at negative 132 divided by 33. And what's that? Negative 4. Now, this was my original intent to go ahead and show you that no matter how you solve a system, you're going to end up with the same answer. I just didn't look at my key beforehand knowing that 8 was a no solution. Does anybody want me to quickly run through the matrix equation on 9 to show that we're going to get the exact same answer? Everybody's okay? Okay. All right. So remember, you've got all these methods now that you can use to solve a system. So even if you find yourself in a test where it's in testing mode, you still got strategies that can help you out. Okay. All right. Unless anybody has any questions, that's all I got. Okay.